Okay, Year 9, equations and inequalities. Here we go. So, when we're trying to solve for equations, at the end of the day, what we're trying to find is our variable, always, right? So, we want to make numbers on one side.
Oh, I know how to do this stuff. Like, then you take away the 5, which equals 1, and then divide by 2, don't you?
That's it.
And
Okay. So then 2x is equal to 1, and then x equals to half. Cool. So let's go a little bit harder then. Let's go with 2x plus 4 over 5 is equal to 6.
Take away 4 over 5.
Yeah, it's just a number, right? You just take away it. Okay, what about this one? 2x plus 4 over 5 is equal to 6.
You want to get rid of the bottom.
Division of 5, so how do I get rid of it?
Equals 30, and then you take away 4.
And bring it back to original, right? Okay. What about now?
You want the 4 on that side, so
Yes.
you take it away,
Yes.
and then you take that away and
Yes.
put it on that side,
So you get something like this.
and then you work that out.
Yes. How do you work
Can you
that
put that
out?
in your calculator?
How?
Oh,
You'll just put
3.
if you put that in your calculator, it will actually work. You put 3 over 2, take away 1 over 6. That's my trick that I taught you. It'll work it out.
Equals 2.
Okay. Yep. That whatever that is. So that is 9 take away 1, which is 8 over 6, which becomes 4 over 3. So 4x over 3 is equal to 2. And then, easy. Make x a subject.
And then you plus 3, times 3.
Yep.
And then that gives you 6, and then divide by 4.
Easy stuff, huh? Well then, what's your problem? All right. Let's do inequations for a second before we do simultaneous equations. Inequations. So the only thing with inequations is the fact that you've got inequalities now. Greater than, equal to, less than or equal to, greater than, or less than. So if I've got a question going x plus 2 is greater than or equal to 6, well, it's actually the same properties as your normal equal to. So you'll take away 2, nice and easy. X is greater than or equal to 4. How do I sketch this on a number line? That's 4. That's 3, that's 2, etc. That's 5, that's 6. If a number is greater than or equal to 4, that means it must be going this way, right? So it must be 5, 6, or 7. So you're going to draw a circle for now, and then draw it to the right. Okay? That should be pretty easy. Now, what you look for is if it's equal to, or is it just greater than? So is it greater than or equal to, or is it actually just greater than? Now, if it's just greater than and it's just an open circle, and then if it's greater than or equal to, you color it in. That's it. Any questions about that one? Okay, but there's 2 conditions that you must take into account. So this is in regards to when you should flip. So you flip when changing sides. So when you change sides, so before I could have written x equals to 2 and 2 equals to x because it's the same thing. But now, if x is greater than 3, it does not mean 3 is greater than x. Okay, and it makes sense. Think of a number here. Let's go 5. Is 5 bigger than 3? Yes. But is 3 bigger than 5? No. So the way you've got to do it, you've got to flip the sign. Is 3 smaller than 5 now? Yes. So when you change sides, you flip. When you times or divide by negative, you also flip. That's it. Those are 2 certain rules. So if you've got this question,
Wait, what's this part of it called?
inequalities. So same rules as equalities, except there's only these 2 rules that you have to take into account.
Wait, number 1. What is that then?
When changing sides.
Wait, when changing sides,
Flip, that's why I wrote it. Yeah, flip the sign. If it's greater than, you change to less than. If it's greater than or equal to, it changes to less than or equal to. That's it, yeah?
Mm-hmm. So it goes for plus, minus, times, and divide.
Yeah.
Okay. Yep.
Times and divide.
Pardon?
Not plus. What did you say again?
It works for plus, minus, times, and divide.
What do you mean by that?
Like, I don't know.
I don't know what you mean either. When you change sides, you flip. When you times or divide by a negative, you flip. So when you times them by a negative, you see here, what am I going to divide by to get rid of the 3?
Where am I looking?
Here.
Yeah, okay.
What am I going to divide by?
Oh, 3.
No, divide by,
Negative 3.
that's it. When you divide or times by a negative, you
Why?
flip.
Because it's not negative. Don't worry about
No, that's it. It's okay. Yes. It's only if it's a negative.
So if timesing and negative.
Timesing or dividing by a negative. So if somehow you've written times by -2, then that means you've got to flip the sign. Like I said, we'll do a couple of these ones.
Yep.
So if I've got -3x plus 2 is greater than or equal to 6, what do I get rid of first?
The 2.
Do I change the sign?
No.
Because I've only takeaway. Yeah, it wasn't a times or divide by a takeaway. So that becomes 4.
Yeah.
Still greater than or equal to. How do I get rid of this -3?
You take it away.
No, I don't. I divide it.
Yeah, that's what I meant.
Right? And then once these two cancel out, you got x on the left hand side. However, it's less than and equal to -4/3. You get that?
Mm-hmm.
I changed the sign.
Okay.
So let's go again. So imagine I had actually okay. What do I get rid of first?
You get rid of the 9
How?
on that side.
How? I know.
Take away.
Yeah. So that becomes -5 is greater than -2x. Oh, do I flip the sign by the way?
No.
But I took away 9.
But doesn't matter.
But then didn't she say take away I flip?
No, because that was a mistake.
I times or divide by a negative, I flip. Times and divide. So another with the takeaway. Okay? Now what?
Divide.
Divide by?
Divide by 2.
No. Divide by?
Negative 2.
Come on, you gotta start saying that. Don't be like, yeah, negative, so like you know it. Because if I don't fix it up now, you're not gonna do it later on. Yep, that's 5. And then what?
And then flip the sign.
Flip the sign. X.
What is it equal? 5.
5 is
Because the x is cancelled away.
sorry, 5/2 is less than x. Yeah?
Mm-hmm.
But usually when you want to, especially when you want to draw your line, you want your x at the front, don't you? So I've got to change sides. So So then x is
X equals 2 over 5.
stop saying equals. Remember, you're out of that mode.
Larger than.
Larger than
Right.
now.
Yeah.
Yes, because you're changing sides. So you've got to flip the sign as well. So in fact, in this question, there's two flips, as you saw. There was one flip that we did here for the negative, and there was also another flip here that we did because we're changing sides. So if x is greater than 5 over 2, well, there's 0 somewhere there. That's 1, and that's 5 over 2 there because that's 2.5. It's greater than, open circle, go to the right, you got yourself a mark. Done.
Okay.
Any questions about the flipping? Do you get where we flipped and everything like that? You want to do another one of those ones?
Yep.
So
And
that's
then can we do where you've got
simultaneous equation.
where it's like
X and Y.
X.
Yep.
So stupid. Can you put one?
You do need to put letters on one side, numbers on the other side. That's rule number 1. So go tell me. It's up to you. You got flexibility.
Eight. No. I'll put it out there. 6 plus 3 is greater than or equal to 8x take away 2. Take away 2x.
Yep. Which becomes 6x in other words.
9.
So you get 9 is greater than or equal to 6x.
X. And then divide by 6.
Divide by 6. Divide by
and
6.
the symbol changes. No, it doesn't.
It doesn't change. You divide by positive.
And then x equals 3.
No, it's not x is equal. It's
No,
very
x is smaller than or equal to.
smaller than, yeah. So you change sides already then. Okay.
Yeah.
Very different.
Could you leave x on that side? You won't get.
Look, no, try not to. Just try to write like this one. Just try to. Because if I say yes now, like I say, in year 10, you have to learn to adapt to this. So, no, you can't leave it like that. That's it.
Yeah.
But it's good to know both.
Mhm.
That's it. Okay, now you want to do simultaneous equations. Okay. Simultaneous equations.
Okay.
Okay. To do simultaneous equations, we require 2 equations. And the reason why we require 2 equations is because we're going to have 2 variables to solve for. So a nice and easy case is something like this. X plus y is equal to 6. And let's go 2x plus y is equal to 9. We're going to label that equation 1. We're going to label that equation 2. Now, in simultaneous equations, you have 2 methods. The first one's going to be called substitution method, and the second one's called the elimination method. Okay, to do the substitution method, as the name says, you would like to make one of the variables the subject. You need to understand what that means then. If you understand if you know it, you need to understand what it means to make one of the subject. That means you gotta have something like this. Y is equal to mx plus b. We've seen that before. Look, y is in terms of x. So y is the subject. This is called the subject. Why? Because everything's in terms of y. Y is equal to this. Or I could write like this. 6x. Y, again, y is the subject. Or you could have written as this. X is the subject this time. Okay, because x is on the left-hand side, for example. So that's what it means by subject. So you just want one of the letters on the one side, everything else on the other side. Okay? Alright, so that's what it means there. When should you do substitution? Well, since you're making one of the variables the subject, it's nicer to do it when one of the 4 letters here has a 1 in front of it. Okay? So the worst one to do for substitution would be this one, in my example. Reason why, because imagine trying to solve for x, you're going to take away y, but then you're going to divide by 2. Right? So what you're going to have is something like this. And then guess what you're going to sub that in? The whole point of substitution, you're going to sub it back into the first one. And then you're going to start dealing with fractions. And the whole point that you've seen up to today, you don't want to deal with fractions. So you should only use substitution when there's at least a number 1 in front of it. Cool? Unless the question specifically says you have to use substitution, then unfortunately you got to do it and you got to deal with it. So use when one variable has a 1 in front of it. Okay. All good so far? Elimination. You would like to eliminate one of the variables. Cool? You'd like to eliminate one of the variables. So if you want to eliminate these variables, the key thing is the number in front of the variable must be the same. But then you'll be like, so you're telling me, Sam, I can only do elimination for y and y because the numbers in front of them are both 1. No, you can actually do it for x and 2x. However, you have to adjust it. How do you adjust? Well, simply, if you know this is the number 2 and you want this to be number 2 for some reason, then you'll just times everything by 2. Because as you times everything by 2, look what's going to happen to that 2. There it is. You got 2x, but you'll also have a 2y, but that's not the point. The point is you just want one variables out of the same. That's it. Now you can eliminate. That is it.
Wait, but then don't you have to do something to the bottom?
This 6, you're going to times it by 2 as well.
Yeah, I know, but doesn't something happen to the bottom?
No.
No. You're timesing it by 1.
Because I'm timesing them technically by 1, for example, yeah. Unless it was, if the numbers were, obviously if I wanted to match a 5 and a 3, well then I have to times this by 3 and I times this by 5. So yes, I have to times both top and bottom. But since this was easier, then no. Cool? That's it. That is it. That's the main difference between the two. So let's do this question now. We've got x plus y equals to 6, and we've got 2x plus y equals to 9. So I'll rewrite it up here. X plus y is equal to 6, and 2x plus y is equal to 9. We're going to do it via both methods to show you. So substitution says make one of them the subject. If I want to make one of them the subject, the smartest choice is either to make with this y, or this x. Why? Go look at this again. Okay, so I'm going to make from the first one the y the subject, just because I can. Cool? Mm-hmm. So y is equal to 6 minus x. If I did make the x a subject, the only reason why I didn't make x a subject, because as I sub in x in here, I'm going to have to times it by 2. So it makes my life a little bit harder. So I just outsmarted and I made y the subject. All good? Alright, so y is 6 minus x. That's called equation number 3 technically. Where am I going to sub in equation number 3?
At the end.
Into what number? Where do I get this from? From 1. So sub 3 into 2. And then this is how it should look like. 2x, there it is, 2x, plus, do I use y anymore?
No.
I don't use y, I use...
You got number 3 from number 1, yeah?
That's it.
Yeah.
Can you see it?
Yeah.
I just took away
something like
from 1. That's the way your teachers keep teaching you. You don't need to know all that crap. I shouldn't say that word, especially when I'm recording. Gotta cut that out. From 1, alright. 2x plus 6 minus z. Do you get where that is? That's just y. Look, y. 2x plus y. But what's y? Y is 6 minus x. Now if you have a look at this line, just have a look at this line for a second. Do you like that line?
No, you want to go with the brackets.
No, don't worry about that. But do you like this? Or did you like 2x plus y equals 9? Which one do you think is better? You really reckon this one's better? Well, to me, when I see that, I see I've got 2 unknowns. When I see this one, how many unknowns do I have now?
2. 1.
I've got the 1 unknown. X is just 1 unknown variable.
Oh, yeah, okay. Got it.
So I like this equation a lot more. And that's it. And then you just got to solve for it. So I get 2x plus 6 minus x equals to 9. 2x take away x is x. You take away 6, bring it to the side. X therefore equals to 3.
Wait, how'd you go with the brackets?
It's not times by anything.
Right.
It's times plus 1, yeah? So there's nothing there. X equals to 3, you're not done. The whole point of this is to find x and y. But you know y is 6 minus x. I'll write it again. From 3, we know that y is 6 minus x. But then what's x this time?
Wait, how did you get...
Solve. 2x, take away x is x. And then 6, when you take away here, is x is 3.
So 2x equals... But isn't it 9 plus 6?
No, but you take away 6, right?
Oh, yeah.
It's on different sides. These are on the same sides. 2x and xy is on the same side, so I simplify. But 6 and 9, they're on different sides, so I have to do the opposite inside.
So x equals 3.
Yep.
And then...
And you're trying to find y, but that's the whole point of you going to find y. Right? So then now you've got y in terms of x. You can just submit x and you're done. So x is 3 and y is 3.
There.
And you can go check it. Is 3 plus 3 6?
Yeah.
Is 2 times 3, which is 6 plus 3, 9?
Yes.
That's it. You got it right. Now let's use the exact same question for elimination. Or I'll make it harder. Let's not use the exact same question because we get it. It will work out exactly the same. But let's do something like this. Okay, can you see that if I get something like this, again, equation 1, equation 2, what would be smarter? Probably substitution.
Yeah.
As long as you have one letter, there it is, that has a 1 in front of it, try to use substitution. If you got the option, which most likely in year 9, you don't. They'll actually tell you have to use substitution, for example, or elimination. Alright? They might not give you the option. In year 11 and 12 and for the rest of your life, you have the option. So you would have to use substitution would be smarter here. But since I don't want you to do it via substitution, we're going to try to do it via elimination. Now, with elimination, I said all you want is the number in front of the variable must be the same. So, as we can see, the numbers are not the same. But I can go, hey, I can just times all this by, what number do you want to times it by? 2. If I times this all by 2, can you see I'm going to get a 2y there? But also I'm going to get a 6x and stuff, but that's not...
It's something like the highest common multiple.
But then, can't you see if I times it by 2, which is the highest common multiple, then I'm going to get the same number here? The highest common multiple is these two. See, you're trying to memorize, but you never understood. It's so much easier. Can't you see if this is 3, I just times it by 2 and times it by 3. So you just times exactly by the opposite numbers. Then you've got the exact same number. 2 times 3 is 6. 3 times 2 is 6. Can't you see you should get the same numbers then?
Yeah.
That's it. Forget about multiples. So same thing with this. If I want to make the y's the same, I just times this by 2 and times this by 1. There's a 1 in front of it. You times it by exact opposites.
Yeah.
That's it. Now, what do you want me to make the subject? The x or the y? You tell me first.
Why?
Okay. Well, y is the easier one. Right? Because that's already a 2. All I have to do is just times the top one by 2. Cool? So then I'll get this. I get 6x plus 2y is equal to 12. And then the bottom one you haven't changed. So 2x plus
Wait,
2y.
Is it from 2 or from
Well, you tell me. Where do you reckon this is from?
2?
Obviously it's from 1. I just told you I times by 2 on the top. Number 1. Again, the way I got taught, I never cared about this whole from 1, from 2. So your teacher unfortunately emphasized that she shouldn't have really. So anyways. Check. Do you have a number in front of both that are the same? Oh, sorry, one of them. That is not the same. But that one is the same, yeah? So you found one. Yay, that's what you need. Okay. How do I get rid of a 2y and a 2y? Now, this part here, there should be either a plus or a minus, depending on the question. Okay? Let's run through this. 2y, should this be plus here, such that it's going to cancel out with this? Should it be 2y plus 2y, or 2y minus plus 2y?
Minus.
Well, let's have a look. 2y plus 2y, that's going to be plus, that's going to give you 4y, so they didn't cancel that. 2y minus plus turns into a minus. 2y, they cancel out equal to 0. You have no more y's when you do that. So yes, you're right, it is just a minus. So then you do that. That's it. 6x, take away 2x is? And then that's how you know it's take away, okay? That's the reason why I wrote it in green. 4x, that's gone. 12 take away 5 is? 7.
Okay.
And that's it. You solve. X equals to 7 over 4. You're done. It's not hard. It's more getting used to when to do each one. Cool. Alright, now, remember, we want to find x and y, of course. So the downside to elimination is you're actually doing substitution in hindsight. Okay, because now you want to make y the subject, and the way you're going to make y the subject is you got to sub x in and still solve for y. Doesn't matter which one I sub it into. Equation 1, equation 2, and arguably equation 3 and equation 4. Does it make a difference which one I sub it into? No, it should still work throughout whichever equation I sub it in. So I'll sub it into the easier one for me, which I think would be equation 1 here. Okay, because that's just single y. So 3 times x, but x is now 7 over 4, plus y is equal to 6. You get that?
Yeah.
You just got to solve for y now. 3 times 7 is 21, 21 over 4, plus y. Plus y equals to 6. And then just y equals to 6 take away. 21 over 4. Any questions about that?
Nope.
Don't worry, I'll be saving all this and I'll be sending it to you onto Edmodo, so it's okay. You'll be able to go look over it. That's why I'm doing all this. Alright, let's go another one. Why are you lagging on it? Alright. Okay. Should I use substitution or elimination here?
Elimination.
Yes. What's your reasoning?
Because it's got numbers all in front of the line.
Yeah, so you can't use substitution. It's not the nice one. All right. Now, the good thing with elimination, do you have a number in front of the letter that's the same? Both letters.
Yes.
Yes. Which one?
2.
The x. Exactly. So do you even need to modify these at all? As in, do you need to times it by 2 or times it by anything?
No.
But the only problem is that is one of them a plus and the other one's like a minus. But that's what this one takes into account. This part here, whatever you put in there is in regards to cancelling this out. You don't know if it's a plus or minus, so don't guess. Don't go, I just think it's always been a minus, I'm just going to do a minus. Just check it out. So if we put a minus, well, this is the way it would work. It would work as 2x minus, right, that's why it's in the middle, and then minus 2x. Well, then now you can see that is actually going to be 4x is going to plus, so that's wrong. It should have been plus. That's it. Or you can just put it in your calculator. Put 2 plus minus 2, hopefully it gives you 0. Any questions? Here we go. 4 plus minus 5. Again, you put it in your calculator, it's going to give you minus 1. And then divide by negative, right?
Yeah.
There's your y. Now, how do I find my x, Jesse?
Sub
Y for,
Y
yeah, that's it.
into
So you're doing substitution, can you see that? Here we go, this is how it would look like. Which one would you sub it into, the first one or second one? Yep, because positive 2x, yeah?
Yeah. 4 times negative 13.
Yeah.
Yep.
What do you use this time?
Elimination.
Yep. Which one do you want to make the same?
Y.
Okay. What do I times all this by?
5.
That's it. Come on, don't make it harder than it is. Do you care about the highest multiple, blah, blah, blah?
No.
Times
You
by...
times the bottom one by 2 bar.
Remember, look at it. If I times by 5, what's that going to turn into?
10.
So then, you can't leave this as 5, right? You got to times it by 2. Remember, it's everything. You can't do it just to one little side. So it becomes like this. And can you see I'm not caring about equation 1, equation 2?
Yeah.
You shouldn't see it that way. You just understand how it works, the mechanics behind it. Here we go. And then, the hard part of the question.
Plus.
You plus it.
Yeah.
Yeah. 15 plus, well, your calculator has to be right?
Yeah.
15 plus 8 is 23. X is equal to 47, and therefore x equals to...
No. 35 plus. 35 plus. Oops. Oh. Yeah, and then divide it by 23.
No, this is the fun part, or the fun part for most poor students. Here we go. You're trying to make y the subject. This is the way it would be. 4, I'm going to sub into the second one. Okay? Just because I can see they're all positives.
Wait, 4.
Yeah, 4. Right?
Yeah.
Times by x.
Are we making equation 4? Equation 3.
No. Equation 3 is already there. That's equation 3. Right? That's what you times everything by. That's equation 1, technically.
Yeah.
It's equation 2, equation 3, equation 4. But now I'm trying to make y the subject. I don't care where. I just told you. It doesn't make a difference where you get it from.
Yeah.
Because you already found x. You can sub x into any of these 4. You just go solve for y. The smarter choice would be either this one or this one.
Yeah.
Because they're both positive, rather than dealing with negatives here. It's up to you. You could have. Doesn't make a difference. So anyways, I'm going to sub into that second one like I said. I'm going to get 4 times this plus 5y is equal to 6. Exactly the same. I have not changed it at all. There it is, there it is, there it is. And then x is now 47 over 23. And that's it. You expand that. (188) over 23 is still 188 over 23. And then you take away, so it looks like this. When you take away it as well.
But
Right.
what's the answer?
I haven't done the answer yet.
Okay.
Right? So you take away. And then you divide by 5. Minus 10 over 23. And just because you get negative numbers and it looks ugly and stuff, you don't think it's wrong. So eventually when you solve for y, it should become negative 10 over 23.